Allegado, I don't even need to give an introduction. You have seen her bio on the website. You've probably heard about her work, and we're very honored and excited to have her share about the experiences she's had in multiple ways that she's weaving knowledge systems. And so we're just want to send our mahalo to you for being with us here today. And we know that what you have to share is going to be very inspiring, and we're excited to hear from you. So without further ado, we can get started. And then after your presentation ends, hopefully we'll have some time for a few questions. So mahalo nui, Rosie, and take it away.
Mahalo Kanoi and everybody for inviting me to talk story with you here today. I'm going to share we just went through this, so I know it should work, but we're going to go through it and I'm going to share my presentation that I have with you folks. And okay. So I want to get started by sharing with you who I am, and who I am is very much tied to my aina and the aina of my ancestors. So I'm going to be sharing with you where I come from so you guys can see how I can relate to all of you. And I'm going to be sharing it through the lens of my aina. So this is my mo'okuauhau. O Louisa Oi Wong Kong no Waihe'e, no Huya Daniel Pamoaho Kalona McGregor, no Haula. Hana o Daniel Pamoaho McGregor e lua he pula pula. O Daniel Pamoaho McGregor e lua no Haula, no Hoya Anita Valerie Branco no Laupa Hoi Hoi. Hana o Diviana Pomaikai McGregor he pula pula. O Diviana Pomaikai McGregor no Ka'ivi Ula, no Hoya Dean Taborsha Allegado no San Narciso, Philippines. Hana o Rosie Analeni he pula pula. O Waiale'e Ku'ukulaivi. O Ahui Manu Kahalu'u Ku'uaina. O ma eli eli ku'upu'u, o kaua po ai hale ku'uwai, o la loa. So I just kind of share that with you so you know that I know all of you guys are teachers from all across the Pai'aina, and my family is also all across the Pai'aina. So I wanted to share that with you as a way to connect, especially because this workshop today talks about, connecting places with curriculum. And so I thought that might be a good way for us to kind of to start. So today I'm just going to talk a little bit about local i'a, or fish ponds, as sentinels for climate change. And before I get started, I did want to say that my training is very much, I'm a microbiologist by training. And in my bio, there are like some fancy words and phrases, but the general gist is that I'm like super interested in how microbes change their environment, both today and throughout Earth's history. And in that way, how has our environment been shaped by our microbes? How has our evolutionary trajectory been shaped? And then in turn, how is the environment changing microbes? And this question comes into play particularly because of climate change, when microbes do a lot of the really important, critical, foundational things in our life, right? We're all breathing, right? So you take a breath in, you take a breath out, take one more breath in, take one more breath out. Every other breath that we take is because there's a microbe in the ocean that is making oxygen for us. And so our environment's changing. So how is the efficiency of those microbes that give us such critical, important functions and abilities and capacities, how is that going to shift? The other thing I wanted to let you know is that I have a lab at the University of Hawaii at Manoa. And one thing that I really, really emphasize is that we have local students come and work in my lab, and that we have put local students into these spaces where they're on the front lines of being the producers of the knowledge, but they also have that experience of working with community practitioners. But in the arena of doing this, and I feel like it's important to bring this up because the more that we do science, it's amazing, but sometimes there is this sense of tension between culture and science. And I just want to start by saying that I really think that that is kind of a false binary. But nevertheless, it has very real roots, even though I do feel like you don't have to choose between science and culture. So what I wanted to share is just like as an Indigenous scientist, the dilemma is real. And I think you have some people on this call who can share those experiences and what it means for them personally. But I just want to give a broad overview just to remind us all that it's important for us to remember that Indigenous communities often have complicated relationships with science. Yeah. So there is these quotes come from Robin Wall Kimmerer's essay, The Fortress, the River, and the Garden. And she talks about how there is this very real intergenerational fear of science. And it's because it's shaped in this legacy of colonization and harmful application of science, right? Like it has been experienced by Native people as being disrespectful to Indigenous rights and sovereignty. But at the same time, right, there's this perception that when we can get Native students, local Pacific Islander students into these professions, that actually has the potential to support Indigenous self-governance and land management. So it's hard because this is what you guys are. I just love teach. I have huge respect for teachers. My whole family actually are teachers. And, so at the same time, we're urged to indigenize science, indigenize our curriculum. But it's really hard because, the structure is not there. And I think that's why you guys are playing such an important role. So we haven't created these mutually beneficial relationships between different knowledge systems. We don't have enough leaders who are fluent in both languages to really resolve these complex questions, and they're fraught with risks on all sides. And I think that's why the role that you guys are playing is so important, because you are going to be growing these leaders. And so I'm so excited that you guys are involved. But the bottom line is, for me, I don't want to be known in my community all the time as a scientist, but I just want people to know, like, I'm always working on the side of people and Honua and the earth. So in kind of thinking through this is just my thinking process, that how do I personally resolve some of these? One of the biggest things, as Kanoi mentioned, weaving, is looking at these parallels between contemporary knowledge production. So you'll see these words and you'll see them, and as teachers, you might be like, this is the scientific method. The way that I think of it is, it's how we produce new knowledge about our natural world. And I look and I think there are a lot of parallels and commonalities between contemporary knowledge production, right? That's like Western educational academia, and Indigenous knowledge production. Both have empiricism and observation. Both utilize prediction and modeling. Both do have manipulation and experimentation. Both have testing, replication, and proof. And both knowledge systems have some way of embedding the knowledge, right? So if you're a Western scientist, unfortunately, you're writing these really esoteric papers that maybe only 40 people really read, and they're in these articles. How do Hawaiians embed this kind of knowledge, both in society at large as well as esoterically? And so I'm going to be using a lot of Hawaiian language, but that's part of, I think, the importance of weaving this together. So, we have these words, and I encourage you to maybe think about and encourage your students to think about how, and it doesn't just have to be Hawaiian, you can do this with all different kinds. Many of you guys might have Pacific Islander students. So what are their words in their home languages, or, everybody's home languages, right? So empiricism and observation, it's, you're using all of your senses, right? Nana, lohe, hanu, breathing, right? You're predicting, you're modeling, right? You're getting out there, you're doing some kilo until you can predict and understand. The manipulation comes from what are the technologies that we're building, right? To become resilient and to change. And the replication and proof is like, okay, when a storm comes, is what I invented gonna hold up, right? Is my fish pond gonna stay standing? Is my lo'ikalo gonna get flooded? Maybe it's supposed to get flooded. Maybe that's part of the technology and the design, right? And then how do we embed that? In Western kind of context, first of all, we like to say it's data, but data is not actually knowledge, because you got to do something, right? With the data, you got to interpret it. And so I think it's one of the most beautiful interpretations of natural world knowledge is in our mele, in our oli, in Hawaiian pule, and then also reinterpreted into our ka'au and mo'olelo, which are, I like to think, I don't like to use the word myths and legends because it makes it seem like it's not real, but I like to say that these are oral traditions, the ka'au and mo'olelo. And then you have ko'ihonua, which are these huge cosmogonic origin stories about place. Ko'i means to carve, so it's literally like, how is this piece of earth carved into what it is today? And that's why these ko'ihonua, these epic stories have people and mo'olelo woven in with actual events, kind of like my own mo'o kuauhau. So I really like to start off with the legend of Lehoʻula, which is the first fish pond. This is actually a picture from my children's storybook, and I use it because it shows like how important the retelling of tales is, and that you can see this story the first time when I read it to my children, and they're like, this is just a cool story. And then you read it again and you realize like, oh, this guy Ku'ula, who we all call an akua, he was probably like the best fish biologist in the world. He had like a supernatural understanding of fish. Like he was so supernatural, people were like, you're like a god. You're like an akua. And he was the head fisherman during a time of famine. And you know, the first like 15 times, maybe 15, 20 years I read this, I skipped over that part. But I realized that is an important part that's in this story because he had to innovate, right? He had to figure out what was going on. And what he did was he took all of his knowledge and he innovated based on his knowledge, his ability to predict what was going to happen. And he built the first fish pond at the confluence of the stream and the ocean. And in that way, constrained nutrients in order to drive primary production. What was powerful is that he solved a problem. It enabled cultivation of fish all year round. People didn't have to go out to, places where there were fish. Maybe there weren't because of storms. This was an important technology that really lent itself to stable populations and pretty much probably together with the Lo'ikalo system drove like geometric growth of the Hawaiian population. A couple hundred years ago. And so the reason why I think it's so interesting to utilize fish ponds as a way to teach our students about climate change is because fish ponds were an innovation of necessity. They were a technology that was invented during a time when there was absence of food, and this guy turned it around. So in my thinking, that's kind of how I apply. That's one reason why I just really, really love studying the fish ponds. I think Lo'iko'i'a just have such huge potential to tell us about our future as by learning about our past. So the methodology that I use is very äina-oriented. I think you can tell by now. And it's also instrument based. So, I'm an oceanographer. I utilize the contemporary technologies to help me study information and gain information to benefit the communities. So this is the general thinking of how I kind of approach it. I think of the Loko'i'a in the past as an ancient ecosystem, high productivity, meaning plenty fish, high biodiversity, right? Like it wasn't like a contemporary aquaculture system we think of today, right? High biodiversity, and it was engineered. It was not a natural system. Then we have a whole bunch of stuff that happened, and the past ecosystem, meaning prior to restoration, let's say at Loko'i'a Ohe'eia, for example, now low productivity, low biodiversity because of major land use change. And what we're trying to do is we're trying to move back. It's still lower productivity, still low biodiversity, but now there's bioculture restoration that's driving that. And, for my studies, I like pull on everything. I pull on all of my instruments. I collect bottle samples to tell me about biogeochemistry. I collect microbes and sequence them to tell us who's there and what they're doing. But I also draw upon local ecological knowledge, like practitioner knowledge, like go talk auntie, uncle, learn, go look in the archives to get that ike kupuna, to get that older knowledge to try and see what I can do to help inform and help improve the fish pond. So what have we learned from studying Hawaiian fish ponds? We've been able to establish a baseline for land use change. We've used it to understand the impact of episodic events. We've also determined the effects of climate change. And most importantly, all that information, we have to transform it into stewardship, just like Ku'ula transformed his information into creating productivity and abundance for his community. Our research from this lens, there are times when, you're just in the laboratory doing your own thing, but it's important that this research, which is centered at Loko'i'a, get transformed into stewardship. So I'm not going to go into huge detail. I'm just going to give you two examples I'm going to actually talk about the understanding the impact of episodic events and climate change, because that's what this workshop is about. But just as a reminder, I don't know how many of you have been to He'ia, but it's been dramatic, the land use change. So we know that Hawaiian aquaculture, based on actual radiocarbon dating of the coral in the wall, we know that He'ia is about 800 years old. So we know we had Hawaiian aquaculture pretty steady along with flooded agroecosystems. So you have this paired, shared thing for about 550 years, right? 1789, that's a couple years past when Cook comes. And then from there until the late 50s, I would say you have plantation style agriculture. So that really shifts a lot. Mangrove is introduced in 1922. You have subsequent urbanization of the area. And then you have this like ginormous 1965 Keapuka flood, which affected the entire Kaneohe area. And so you have this huge change. You can see in these pictures from 1928, this functional fish pond, you can still see the lo'i in that wetland system because of all of the change and urbanization, now that wetland is like grass, and now He'ia fish pond is all sedimented. So this is part of what my lab does is we are kind of looking at what is the functional consequences of restoring this fish pond and trying to get it towards how can what we know inform food production, and especially because they're trying to do this at a time when climate change is happening, right? So this is what it looked like in 2003, 20 years ago. Even just 10 years ago, there was dramatic changes. You can see the fish pen, and this image that I'm showing you here kind of shows you the blocks of restoration that they've done over the past 20 years. It's been pretty dramatic. Just to kind of give you a sense of like, this is where my lab is looking at in the fish pond. We have, specific areas we look at so we can capture a picture and put it together. You guys have been to Loko'i'a, so you can see, what makaha look like. Part of the studies that I did was to look at the change of this huge restoration of this ocean break that was a result of the Keapuka flood, and it's now a totally restored makaha, and it's kaho'okele. And then also the impact of restoring and removing invasive species. So taking out this egret island, which was a rookery for 40,000 cattle egrets, mega poop, guys, and mangrove removal. That's kind of some of what we study. So I just wanted to give you a quick example as it pertains to climate. One of the things I think we talk about a lot are how are these multi-annual cycles changing in the face of climate change. And that can be hard to explain to students, but fish ponds are a great way to think about it. So in 2009, that was the last time we had a really strong El Nino. We had a strong El Nino in 2014, 2015, 2016, but this one was dramatic for the fish pond. So the fish pond was starting to grow moi. If any of you guys have ever had Pacific threadfin Polydactylus sexaphilis, it's known to be super delicious, and He'ia fish pond historically was known to produce some of the most ono tasting moi. And so they were doing multiple rounds of threadfin, produced slowly as it became more functional. And this is a record of how much fish was being sold between 2006 and 2008. However, over a week-long period in May and October of 2009, over 10,000 fish had died in net pens. So the question that we looked at was what was going on? Why was the weather unusual in some way? What were the ocean conditions? And so we assessed a number of meteorological conditions in the fish pond, also looked at what else was going on in Kaneohe Bay. But having relationships with the fish pond practitioners was also super important because they were doing their own record keeping, and that was really valuable too. So I want to emphasize community knowledge is so valuable. So they were keeping track, of course, of their steward book. And you can see that they were that's where we got a lot of our hypotheses for trying to look at what might have been causing this. So you can see they noted, oh, there's a super low tide. Hey, guess what? We're right in the king tides right now. People always talk about the super high tide, but the other consequence of the king tide is the super low tide. So it was a super low tide, hot water, you can see cool below. That's stratification. So here I am, I'm translating. When I looked at their logbook, I'm translating it into like science hypotheses. Low tide hit, the fish in the second pen weren't eating. Ooh, stressed. Then you can see over, oh, there's no wind. It's vela loa, okay? I'm not going to translate some of it because when the fish started dying, there was like some swear words, the F-bombs they put inside. Anyway, October observations, major rain, flooding, muggy, icky kind weather, VOG to the max, no trades. So we took instrument data that we had from in the pond, and we realized that there were elevated sea surface temperatures. That's what SST is throughout the summer. So that's one of the consequences. A lot of people think with climate change, oh, we're just going to have sea level rise, but elevated temperature, it happens too. And what we realized is the fish pond showed us that there was what's called a marine heat wave. And you'll see that more in the news, and it can cause huge, massive die-offs. In fact, just last year in the Pacific Northwest, it caused the die-off of like millions of shellfish. And so that's what was happening in the fish pond, is there was a marine heat wave. We also, based on their the logs, we went and we looked at the trade winds. And so we noticed that there were trade winds up until May 17th, but then there were frequent no wind periods. And the same thing happened in October. So you could see, why weren't there fish kills all throughout? It was only at these two kind of areas. So it was heat plus lack of wind. And so we realized if there's no wind, there's no mixing, which leads to stratification. And that was backed up by our fish pond practitioners. So this is actually the wind data that we were able to confirm. And so don't worry about this like craziness, but all you have to know is like whenever you see these crazy little things, it means that there's almost no wind and the needle is going nuts. It's just kind of bobbing around. But when it's steady, like steady trade winds at 15 to 20 miles per hour, then it's constant. And so you can see the only time periods where you had this weird crazy thing because there was no wind was May and October, which coincided with the fish kill. So what we realized was that the fish pond told us that there were no winds, there was very warm temperatures, and maybe that's what was going on, because one of the components of an El Nino is that we have a decrease in trade winds. So we know that an El Nino has less rainfall October through May, weaker winds, the trade winds are less consistent, and warmer ocean temperatures. And what we saw was that during this 2009 El Nino, this is why we call it an El Nino Modoki. It turns out not all El Ninos are the same. Some of you who are familiar know it's this warm body of water that comes out across from the Eastern Pacific. But there's other modes. Yeah, it's like flavors of ice cream. Not all the flavors. That's the vanilla one. This is the one with chocolate. So there's this other mode called El Nino Modoki. And what it is that the heat isn't as concentrated like how it is in the left-hand picture. It's spread out, but it also is spread out over the middle of the Pacific, which is where Hawaii is. So when we have that kind, then that's when we're in trouble. Good question, Debbie. How do we prepare? So one thing I did was to wonder, it made me start wondering, what does El Nino look like in Hawaii? Well, if you just talk story to a lot of people, right? Like just anecdotal, right? People always say, it's a little bit wetter than normal. Not like it's constant rain, but it's like it's wetter because there's hurricane storms and flooding. Hello, we're gonna have a tropical storm passing through this weekend. There's higher sea surface temperatures, meaning we can see coral bleaching, and now we know there's fish kills. And then there's weaker trade winds, and so if volcano is active, if there's weaker trade winds, all of us are like choking because there's fog. In the winter, it's drier than normal, and that might mean there's drought, famine, or low stream flow. Okay, so that was what I wanted to do, and it made me really wonder, and this is the reason why, this is going into my second project now. I really wondered, how can we apply this to Hawaii? it really made me dig deeper and be like, how do local practitioners interpret multi-annual climate patterns? And the reason why I really wanted to know is because I was like, this word, El Nino, like, where does it come from? What were our words? What are our words for these climate phenomena? Did we even have them? Okay, turns out yes. So this word El Nino, guess what? It was actually appropriated from indigenous people. 17th century indigenous Chilean fishermen recognized abnormalities in their fisheries that happen around Christmas time. And El Nino is named after the Christ child. So in Chile, their El Nino, you saw from that like picture, right? The warm body of water that flows across. You have these warm sea surface temperatures and less fish. And then when climate scientists began to notice this bigger picture, they were like, who around here is using this term? Oh yeah, okay, these guys, we'll just call it El Nino. Nobody ever tells you that these names came from indigenous people, indigenous fishers. Guess what? In Samoa, they also have their own name. So it's called kaimake. And if you know Hawaiian, you know kaimake means dead ocean. And that's because, okay, guess what? El Nino is not the same everywhere, right? In Samoa, what happens is that the ocean water, the winds change so much that it pushes wind like towards the Eastern Pacific. And so their sea levels drop. And so during a El Nino, the lowered sea levels expose the reef, which means it's kind of stink, right? It's this flat top. And so that's the smell of the reef. And that's how they know that an El Nino is around, or well, they don't call it an El Nino, they call it a kaimake. So I wanted to know what was our words because we have these observations. So that drove me to look to the Hawaiian language newspapers, right? And I can skip through this because I want us to be able to have some talk story time. But I wanted to say the Hawaiian language newspapers and Hawaiian language can be a way for us to increase our historical record of climate in Hawaii. So, this is just quick. Basically, we all know Hawaiians had super high literacy rate, highest in the world, 99%. And it was because of our newspapers. And what's important to know about why newspapers are incredibly awesome is that oral knowledge was documented while customary practices were still widespread, meaning that people were still farming the land, fishing, doing all of these things. And that's why it's so amazing. And so Nüpepa were intentional repositories of customary knowledge. This comes from Kalama, Hawaii in 1834. I'm just translating one part of this whole thing. This article is the first year in which newspapers were printed. And in it, the writer asked the chiefs to put their ancestral knowledge into print so that it may be perpetuated. Once you pass away, traditional knowledge may disappear completely. So to avoid that, let it be printed as a sign that we care of the things of old. And guess what? There's hundreds of newspapers. Hawaii has, I'm going to just come out and say we do. We have the largest written archive of history in the Pacific, and possibly, if you include us with the United States, possibly in the United States. We have 1.5 million pages of text about just the life of Hawaii. Okay, so what about ENSO? Basically, what I felt like was, can we coalesce these instrument observations with historical observations and tell us and help us to find what does El Nino look like back then? What does it look like now? And I wanted to know, like, what are our words? Like, what were we saying? So I'm going to skip this because it's kind of crazy science. And I also want us to have time to talk story because I was talking too long. The basic idea is we have all these digitized newspapers that are searchable. And I did keyword searches. And I basically, through this keyword searches, I was able to increase the amount of vocabulary around these long-term climate phenomenon. So here are just some examples in this table of words that are climate words that, if any of you would like to readopt them and normalize them and bring them back into practice, I would love that. Some of these words are super common, like va malo'o. Malo'o means dry, va means period of time. That's a drought. So these are actual words that I found in the Nüpepa to describe these kind of things that had been going on. Okay. So then of course, because I'm a scientist, I have to get like numerical. And so what I did was, we went and we looked in the newspapers for how many times are people talking about either drought or flood or, strong storms. So in this case, we were looking at how many times are people talking about rains or droughts, and I overlapped that with how much from what we know from the historical record about when there was El Nino. And guess what? It overlapped. During an El Nino, people talked less about the rain in the summertime and talked more about droughts in the wintertime. This is just an article. I mean, I just love it. This is like, just so you know what I'm actually seeing when I read this. So this is how I can draw out information that's in a written form, and then I can like make that into numbers and graphs. So this is just an article about Kaupo. There's crisis now in this land. The rain hasn't fallen. The land is parched as if God is keeping prosperity on this side of Kipahulu. And from Kaupo on, there's no rain. So these articles, right, they give really excellent geographical information. I know exactly where it is. This is on Maui. I can see. So this is how I kind of start to put together this information. And then about Kahiki Nui, this is also on Maui. The features of this land are not like before. It's as if it has been burned by fire. The mountain is scorching and there is no grass growing. So I get geographical, I get biological information, all this kind of stuff. And this is just from that one period of time in 1878 when there was like a really strong El Nino. So I'm going to skip this just to let you know it's not super easy because, what is the Hawaiian word for storm and rain? You go look that in the dictionary. There's like 62,000 words mentioning ino. There's 23,000 for makani and like quarter of a million for rain. And then you have to filter out and find and evaluate translations because sometimes there's a lot of really interesting translations, like they translated Shakespeare's Tempest into Hawaiian. And what's the word for tempest? Hello, it's a storm. So you got to be like, oh my, I tricked myself many times where I was like, oh my God, there was this huge hurricane. And then I'm like, oh, no. They're like translating a story about a hurricane. It's not like a real thing. So it's overwhelming, but it's super fun. And I just wanted to leave you with the idea that what I found were not only common words for drought, like everyday words, I also found akua names that relate to what I think are El Nino words. And so you have descriptors and then you have akua. And so for me, it came full circle because Ku'ula, who was an akua of fish ponds, took me all the way through to help me find the akua of, these big climate weather systems. And indeed, so that was what I found was Kane Puniu seems to be the akua name that was most associated with this climate phenomenon. And we know that akua Kane is the primal element. He is the sun. Well, akua Kane represents the sun, nuclear heat, and isn't that the driver of climate cycles and systems? And I actually pulled this off of Noah's Teach for the Climate website, that if you look at how they describe one of the most essential teaching principles about the sun, and it matches perfectly with Hawaiian concepts also of what akua Kane does. Okay, so I'm sorry I went over, but I just want to thank you very much for listening to me. And these are all of the support that I've had to do this research. And I want to mahalo my academic collaborators at UH, as well as everybody in my lab and my students. Stop sharing.
Mahalo nui, Dr. Aligado. I was just trying to figure out how to put the clapping emoji. Mahalo, just mind-blowing, amazing, perfect way to bring us home.
Do that. Hi, Rosie. I'm Debbie. Thank you so much. What an incredible honor that we got to hear you speak today. And I was just frantically taking notes and getting so inspired, maybe a little bit too much in the chat. Sorry, everyone. But I guess what I wondered is if you'd be willing, just going to hit right in there. I really see your work as being an awesome case study for students studying oceanography, marine science, and exploring. And just wondered, have you had a chance to look at designing lessons for, different grade levels, or any thoughts on that?
Yes, so one of the great things about working with Heia, Paipai o Heia, is that they have a really strong educational program. And so I haven't done it formally in terms of like school lessons, but I've worked with the fish pond practitioners who have educational programs to be like, oh yeah, how can we work this in? So little modules. I also have students who are very interested, like I guess in my lab, I'm not always like, I'm not trying to churn out little scientists like me. So I have students who do want to become educators. And so part of some of their projects and their natural interests have been to try and start to develop more educational curricula. And so it hasn't been on this, but like we've made little guides to what are the plankton and like what are the zooplankton and like how can you find it. So if people, if you go with a net, this is all stuff I didn't talk about, but I do all this like other things. But so that's the type of curriculum. But yeah, it would be really cool to develop climate curriculum. I haven't done it for the fish pond yet.
Sounds like a grant to write, Debbie.
That's right. Let's do it.
All right, does anyone have maybe one more question? I know we're running over, but this is such rich discussion that I think we can, if people are okay, we can push back a little bit.
There's some questions in the chat. Like Patty's question would be really interesting.
Okay, let's see. Patty's question, if I can have help finding it.
Yeah, I think she asked, could you please explain the meaning or kauna of the word kane puniu?
Oh yeah, so puniu it's a metaphor for your skull, but niu means coconut, right? So the puniu is the little coconut, the coconut. And basically it's the idea that it's so hot, your brain is like dizzy, and it explains the heat that is associated with when we have those El Nino days when we don't have the winds blowing and you're just like, oh my God, it's so hot. So there's a whole olelo no iao that says, "Aue kani puniu ikavela ana okala." So it's, oh no, kane of the dizzy head in the heat of the day. Yeah. Oh, and actually there is some curriculum on using Hawaiian language newspapers, and I'll go find it and I'll drop the link in the chat. I didn't make it, but curriculum development at UH did.
Can you drop the link to the curriculum that you were talking about with the microbes and the plankton too?
Yes, sure. So some of those were developed by the Center for Microbial Oceanography, Research and Education, Seymour, and they actually have plankton kits that teachers can check out. And it comes with everything, like it comes with the whole lesson plan, and it even comes with the plankton net. So you can borrow it. Yeah, I'll drop those in the link. So you guys can like go on with your program and I'll find these and drop them in.
Awesome. Mahalo nui, Rosie. We will definitely make sure to bridge that communication and make sure we follow up with those resources. Mahalo, mahalo, mahalo. It's just amazing so many ways that you're putting these concepts into practice, and mahalo for really powerfully demonstrating how you're weaving knowledge systems and looking at scientific process through an OEV lens and trying to not see science and culture as separate. So there's so much more I could say, but I know that we have to move on. And I know you have a busy day, Dr. Alegado. So if you want to stay on, you're welcome to, but we will say ahui ho to you now and mahalo nui.